Here's a quick introduction to our next wrap. We're going to be looking at some roof trusses, and a roof truss is something that holds a roof up. All right, I think I've talked about these and showed you these. These are roof trusses I put in the house I just built, or the part of the house I just built, and so they all got to go up. They all got to be strong, of course, and they've got to be in the same congruent shapes. And notice they're all broken into triangles. And this design, this Howe truss is the name of this truss, is broken into right triangles specifically. You see a whole bunch of right triangles there. We've got some little right triangles going on here, right there. We've got some big right triangles going on here. Whoops. Okay, we've got these little right triangles on here. So lots of right triangles going on, all right? So we're going to use all of our trigonometry to find all of the angles and all of the sides and all the lengths in this truss, all right? That's very useful to know because when this is built, we've got to build lots of these, and so a plan is made up by somebody who's is an engineer there, and the engineer has to tell those guys that are going to make this exactly how long each length needs to be, so they can make the boards that way and make a whole bunch of them exactly the same. So you can read through the directions there, but there's some important highlights here is that it's made of right triangles. We have the top chord is this length right here, some vocabulary. This is called the bottom chord, okay? And the top chord is broken into 3 even lengths. Bottom chord is broken into 6 even lengths. Okay, so we're going to use some trigonometry to calculate all these angles. All right, I'm going to round to 2 decimal places. Keep that in mind at the end. Now you're going to want to probably have more than that as you work, but that'll be good. Okay, so first thing we need to do is we need to calculate the angle of this roof using the slope. The slope is given to us right here. Okay, it's a slope of 7/12. So we can use that. You're going to need to use that to find this angle. Okay, so we've got this angle here. Okay, and maybe we'll call this angle 1, which we will. I'll show you that on the other side. So we know something about this, right? This is a right triangle. You got to ask yourself, is this sine, cosine, and tangent? Or tangent, I should say. Hopefully you see that. Oh, that's tangent. So the tangent of, sloppy there, tangent of angle 1 is 7/12. Okay, so we're going to need to use some inverse tangent to find the angles. Remember, inverse tangent will find the measure of angle 1. Okay, I'll let you figure that out. Okay, there's going to be a lot of things that we're going to figure out. So we're going to go to the next page here, and I'll show you how we're going to kind of organize this. You're going to find out what that angle is. And then we're going to go from there and use that. So let's look at the next page and see how we can organize this. All right. So on this page, notice I've labeled all of the lengths and the angles so we can record this, okay? And so you don't have to go in order, angle 1, angle 2, angle 3, it doesn't matter, okay? But you'll notice a couple things. There's a lot of parallel lines, so we know some things about parallel lines and alternate interior angles, okay? Now be careful. Is angle 8 and angle 7, are those consecutive angles? Are they going to be congruent? They're actually not, because this line is not parallel to that line. So be careful. However, these vertical lines are parallel. So there's going to be some corresponding angles, like 3 and 4 are corresponding. Okay? So some are corresponding, some are not. Also, this, we know C and D is congruent, because this is broken up into 3 parts. So you've got some triangles going on there, like some isosceles triangles. So look for those. Okay, so lots of geometry you can use here. So we already figured out a way to get this angle here, okay? And so we know that the inverse tangent of 7/12 is going to give us the measure of angle 1. Let you figure that out, all right? Now, lengths, let's look lengths here. If you look at the whole design on the front side, you'll find out that this whole thing here, let me draw that differently. this whole length of the whole truss is 43 feet and 6 inches. Whoops. All right, that comes out to be 522 inches. Now, this is an isosceles triangle, so cut that in half, and this is 261 inches. And now that's enough to figure out A, B, or B, C, and D because they're split into thirds, okay? And so as you're doing this, record your work, keep it organized, all right? If you're going to find out that D is 261 divided by 3 and let you figure out what that is, okay? And then once you know what D is, you can use your angle here, and you can use a sine, cosine, or tangent equation to find K, maybe, all right? So the tangent of angle 1 is K over D. And you're about to find out what D is, so plug that in and work it out. So show your steps, keep it organized, all right? When you get an answer there, I would recommend to label it in your drawing, okay? And keep going from there, all right? Now, notice some of these, like F is not in a right triangle, but F is part of a right triangle. So in F here, if you figure out this hypotenuse of this triangle and then subtract G from it, you'll have F. Or even maybe better yet, notice this. Remember that this top chord is broken into thirds, right? So once you know G, you actually know F and E, all right? So, all right, keep working on that. Be creative, keep organized, show your steps, and have fun with it. One last little thing is that when you're recording your angles here, throughout the problem, you may want to record 3 or 4 decimal places and then round off to 2 for your final answers, okay? But if you're reusing something, like when you find this D and you're plugging it in here, you probably should have 3 or 4 decimal places there, okay? All right. Go figure out some trusses. Be engineers. Be creative.